Today's problem was submitted by a viewer, and it says, which positive integer n satisfies the equation 3 over n cubed plus 4 over n cubed plus 5 over n cubed, and so on, up to, we have n cubed minus 4 over n cubed plus n cubed minus 3 over n cubed equals 60. Okay. Positive integer n. So let's write this out. The first couple things that are coming through my mind here are to try to multiply through by n cubed and try to count how many terms there are here and maybe just write this as a polynomial in n. Wait, this is a little weird. Okay, so I have that. So how many terms do I have in total? If I included 1 over n cubed plus 2 over n cubed and n cubed minus 2 over n cubed plus n cubed minus 1 over n cubed plus n cubed minus, so just n cubed over n cubed. This gives us that's n cubed terms in total. So I have n cubed minus 5 terms in total. So I've multiplied both sides by n cubed. It's a little weird because I think that's fine. We have, even though we have like a variable number of terms on the left, if I fix n cubed, this is true. Okay, and the left-hand side is the sum of k. K goes from 1 to n cubed minus 3. But then I have to subtract the first two terms, so that's this minus 3. I want that to be equal to 60 n cubed. Okay, so this is, this is just an arithmetic series. So I take the sum of the first term and last term, divide by 2, and multiply by the number of terms. Okay, so now I see if I work this all out, I'll get a quadratic equation with respect to n cubed. I guess I'll just expand this. Oh, we actually get some nice cancellation here. Okay, so n to the 6 minus 5 n cubed is equal to 120 n cubed. So I get n cubed is equal to 125. Yeah, and n is equal to 5. we're going to ignore the solution n is equal to 0. Of course, we're dividing by n cubed everywhere, so n should not be equal to 0. And we could maybe check that this works. So I have the denominator is always 5 cubed, so 3 plus 4 plus 5 plus and so on plus n cubed is 125. So I have 120 plus 121 plus 122, all divided by 125. Is that equal to 60? Okay, well I have it should be, right? The numerator how many terms are there here? Average size term is 125 over 2. The number of terms is the number of terms is 120. Yeah. So this is clearly equal to 60. Yeah. So that's my answer, 5. It's a little, you have to think a little bit about whether some of your standard operations work when the number of terms in the series depends on a variable, an index variable in the series, although it's not really an index, is it? Well, anyway, the number of terms in the series is kind of is variable. But yeah, I guess it doesn't even make sense for the number of terms in the series to depend on the index of the series. But anyway, you know, I guess the way that I convinced myself that it's legal to just multiply through by a common denominator here is if we fix a single value of n, that's what we're looking for. We're looking for this to be satisfied for a single fixed value of n. So then if you fix that value of n, multiply through by n cubed. There you go. Everything is just a number at this point. Okay. Yeah, I'm just confusing myself and I'm rambling here. It was a nice problem. I thought I was going to have to solve a general quadratic thing, but that cancellation right there was very convenient. I'm sure that's why they set the problem up the way they did. Thanks for the submission. Thanks for watching.